All right, so what you see here, and I guess I should start with a caveat, in that I don't know all of the physics and rendering techniques that are going on underneath this. What I will speak to is sort of the dynamic dicing that's going on. I will say that, well, actually, I guess I would like your reaction. How does it look in terms of the characteristics of the water?
It doesn't behave like any water I've ever seen before.
It's moving slowly.
It's moving everywhere at once.
Yeah.
It looks wet though. I think that's probably
Did you mean that in a good way or a bad way?
Okay. So what's going on here? Can you, let's see.
Wireframe?
Yeah, we can go to Wireframe. So there's a lot of geometry here. Now let's, in Wireframe, let's scale back the LOD to a coarse representation. So this is the representation at its coarsest, and you can see, it's being animated. I'm presuming that there's physics involved.
No, this is basically just doing a animation. That's it. That's why it looks weird.
Yeah. Okay.
The physics is not sophisticated.
Right.
This is just a example of tessellation.
And let's see. Did we take the frame rate off this? I forget. Oh yeah, no, it's just small, and with my eyes I can barely see it. Okay, so the frame rate at this point is around 250 frames a second, just to give you an idea. So let's crank the tessellation back up just for...
there it starts looking pretty good.
Yeah.
That's pretty cool.
So that's around 130 frames a second. So I'll be sort of fast and loose, and I'll say that's a factor of 2. But the geometry amplification is probably between a factor of 100 and a factor of 1,000 in terms of the geometric fidelity you get.
1,000.
Yeah, okay. The geometric fidelity you get from this rendering. I'll also add, obviously, this terrain is being tessellated as well. So we've got displacement mapping being applied, some sophisticated shaders with bump mapping as well. Obviously reflections, refraction going on. There's a lot happening in this image. Let's see.
So I think it's really important to point out that we're going from the low resolution to the high resolution. It's stressing the tessellation engines, and it's now increased geometry by about a factor of 1,000. Yet the frame rate has only slowed down by about factor 2,
Yeah.
something like that.
I guess another thing.
And this is very distressing the tessellation engines and not other parts of the design.
Correct.
Yeah.
Yeah. Right.
So another thing I'd like to point out. Can we go back to the wireframe? First of all, this is spectacular, and it was put together on a pretty tight schedule. But this is a very naive use of tessellation in the sense that in the distance here, this is tessellated extremely densely. You can see how it's actually kind of at probably an appropriate density here in the foreground. They're small triangles, but they're not, sort of pixel sized. In the background, in the distance, the screen is just saturated with sort of pixel-sized triangles. Now, the hardware supports the ability to vary the level of detail from the front of the scene to the back of the scene, so they should all be about this density all the way back into the horizon. So in fact, from the perspective of the fidelity of the image, the quality of the image, we could be running much, much faster if the shaders that were being used were more sophisticated about how they computed the level of detail. Because in the distance, the level of detail should be lower. But in fact, my understanding of the way the demonstration was built, the level of detail is the same everywhere. You just have a slider in the corner that lets you crank it up and down. Whereas if the programmer had taken the camera position into account, you could vary the level of detail appropriately across the scene. Okay. Any questions about this? Because we should switch to hair, and I'm probably taking up a lot more time than.
You're good.
Okay, fine. All right, so the second demo we wanted to show you was the real-time rendering of the hair.
And that one does do the level of details.
Yeah, we can show
Gives
it.
you
Zoom.
Right.
This takes about 15 seconds.
So this demo was used in part to help validate the design. There was an implementation of this demonstration about 2 years ago that helped us validate both the programming interface and the hardware design itself. So what's going on here is physics is, I don't know if we can get the light.
Spin around the other side.
Yeah.
There we go. That's a little bit better.
Do I turn the head too? Or?
Sure, you can move it around. But there are several things being brought to bear here. Physics is being used to model, as I said, model the movement of the hair and how it interacts with the mannequin head and shoulders. There were versions of this, I don't know if this has this, that could respond to wind and other phenomena.
Turn the slider.
You see how the hair is moving off the shoulder? Anyway, you get the idea. So as I was saying, the tessellator produces line strips, and then the geometry shader takes those line strips and turns them into little slivery triangles, and that's how this is rendered. And then there's an isotropic rendering model applied to the hairs to give you this fairly realistic appearance. Another thing that is worth noting, now we have a canned sequence, is this is running at about 25 frames a second. If we push this out into the distance, the level of detail that's applied to the hairs, the number of hairs that are generated and so forth, gets dropped back, and we're now at around 45 frames a second. It says 42.
So what this means is,
42.9.
this means if we have multiple characters on the screen, they all can have good hair and still have a decent frame rate.
Right. So and this idea of scalability within the scene applies to all these different applications of tessellation, in the sense that if you have characters that are displacement mapped in order to create geometric fidelity, if they're far from the camera, they can be rendered extremely efficiently, and you can have large numbers of them. Whereas if you have one character right up filling the whole screen, you can devote all the geometry to that.
But we want that to be a dynamic thing, or you don't have
Right.
to make a static choice.
Right, and I guess it's also important that you don't. It's not. Sure, what's happening here? And it's also not a burden in the authoring process, in the sense that you don't have to create handcrafted levels of detail. So, any questions about the hair? Okay, we have a lot of stuff to cover, so perhaps we should get back to it.